Welcome to our workshop session. I'm Evan Shortiss. I'm a developer advocate at Red Hat, formerly a technical marketing manager, and I'm joined by Vamsi, who is also a technical marketing manager, and we're here to talk about cloud-native APIs and identity management for API products and real-time API products. So the first thing you might ask is, what is an API? If you're at this event, maybe you already know, but let's start with the basics. So an API is an interface to software component that can be invoked at a distance over a communications network using standards-based technologies. Basically, APIs are a technical construct, but they can be understood as interfaces through which business is done using software. APIs, in the sense of what we're talking about today, we're typically talking about RESTful APIs that communicate over HTTP. So that's generally what we're talking about today, but you can also have APIs that, of course, are communicating over other specifications too. And APIs, as most people probably will know, are everywhere. Today, they're mission critical for most businesses. Basically, businesses are defining APIs for their partners, customers, vendors, and everyone else to use to automate interactions with their backend systems. And it's fundamental to company agility and competitiveness in a modern environment. Particularly if we think of web and mobile applications and the evolution we've seen in those over the past 10 years or so, there's been a huge increase in the volume and availability of APIs from all sorts of customers and companies to enable that digital transformation. And I guess you'd call it omni-channel experience, where you can, talk to your Alexa and turn your lights on or off, or you can talk to your Google Home or even your phone itself and use apps, and the experience follows you everywhere, because generally those experiences are enabled through quality APIs. But there's more to an API than simply building it and exposing it to the world. There's lots of management aspects you have to think about, and that's what we're going to talk about today. So at the top of this diagram here, we have the iceberg. And the iceberg analogy is a good one here, because while, yes, most people just think that your HTTP API is REST endpoints, really under the covers or behind the scenes, there's a lot more going on. When you build your API, you probably want to separate these concerns under the iceberg from the actual development itself, or at least somewhat separate it. So things like security and authentication, version control, documentation, or exposing a portal for developers to visit and sign up and get their API keys or credentials. Also reliability and other types of policies that handle traffic. These are all things that are incredibly important to an API strategy that are not necessarily concerns for the core API endpoint development. And that's where an API management platform comes in. And then on the right, you can see we've other concerns as well, such as alerting, monitoring, metering, and billing if your API is metered and billed. And of course, we need to think about the lifecycle management for the API as it evolves as well. So when we think of full lifecycle API management, we have this kind of figure 8 diagram here. And we begin with the strategy, which is before you even start building your API, you need to think about the use case. Who's going to use this? And how are you going to define, design, and develop this API? So you should start off with this thoughtful design stage. You should mock it out, have people test it. And then actually, once you're happy with that steps 1 through 4, you can go ahead and do a real implementation. So that implementation should be, your Java or your Golang or your Node.js backend. That's actually the real API, as opposed to a mocked out one you used during that early exploratory phase of your API development process. Once you're happy with your implementation, you can deploy it maybe on Kubernetes or on your favorite cloud. Then you need to secure it, of course, which is where we're starting to get into the API management side of things, and the management aspect itself is what comes next. And then we move over into the stage of enabling discovery. So when it comes to discovery, you obviously want people to be able to log into a portal, find your API, you want them to be able to use it then and develop their own solutions using your API. Then you're going to want them to consume it in their production applications. Then from your perspective, you're going to want to monitor it to make sure you're hitting the correct uptime, that you're not seeing request errors that are too high. You want to keep response time low. And then you need to, of course, monetize or potentially monetize your API depending on your management strategy. It could be, you could have rate limits enforced, or you could have monetization strategies in place where if people are making a certain number of requests, that puts them in a certain tier for payment. And from Red Hat's perspective, we support developers and organizations through every step of this journey. We have things like API Designer for the early design stage, Microx for mocking out the API, endpoints when you're in that early design stage. And then when it comes to actually deploying and building it, we have all sorts of tooling like Ansible automation to automate the process. We have Red Hat runtimes for building the implementation itself. We have EAP if you're deploying traditional Java applications, and we have other middleware such as streams for Apache Kafka if you need real-time elements in your API. And then, of course, Red Hat Single Sign-On, which is backed by the upstream Keycloak project for the identity management aspects. And then finally, for the actual API management pieces, we have Red Hat OpenShift API management, which we'll show in the workshop today. And if you're not familiar with how OpenShift API management works, or API management in general, or at least certain API management products, typically there's a separation of concerns here where the API manager itself, the platform, is separate to the API gateways. And so here in this diagram, you can see at the top, we have the manager, and that exposes the developer portal that people can use to sign up for your API, but it also exposes an admin portal that your own internal teams will use to manage your API itself. And the gateway can be deployed on-premise or on your cloud of choice, or in any environment, even on the edge, really. And that API gateway will synchronize its settings with the management portal. And based on those settings, it will perform the configured policies for incoming API requests from developer applications. If those requests satisfy the authorization configuration and policies, it'll be allowed through to your API backend to fulfill the request. And of course, the gateway will also optionally integrate with a OpenID Connect identity provider if you've configured that. So the benefit here of having this separation is that your gateways can continue running while the API manager is being updated, or if it goes down briefly, because the settings are constantly being synchronized or asynchronously synchronized to the API gateway. So next slide. So for the workshop today, we're going to just do some setting of a scene so you understand a use case we're going to present to demonstrate these concepts of API management. The use case today is smart cities, so IoT and edge devices that are connected to a smart city backend, and the data gathered by all of these systems is processed in an asynchronous fashion in real time and exposed by APIs. And those APIs can be used by application developers to provide experiences for end users. So in our case, I'll show you two applications in a moment that are powered by the APIs that we've provided. So assume we have a parking sensor network on the right that's attached to all the parking meters in, say, for example, downtown Los Angeles. Those are constantly sending their status to a backend, maybe via an IoT protocol or a lightweight protocol like MQTT. That can be processed using Red Hat's middleware and put into Kafka topics and processed asynchronously. And eventually it'll end up probably in a database. And that database can then be queried by your API and displayed in front-end applications that are developed for mobile devices or web browsers using technologies such as React or Node.js. And your API implementation can be written in something like Java or Quarkus for Java. And for the particular use case we're going to talk about today with the smart cities, we could take the example of an internal application. So the city could have engineers or maintenance engineers. They need to be aware of faulty meters, and when they put them into, or when they are faulty, they need to get notified, be able to change the status of the meter to maintenance mode, and then go out and update it or fix the meter and post the updated status. So this could all be done via a mobile application, for example, or a web interface. And in this kind of architecture, where an API management solution would sit would be between the actual back-end implementation of the API and the front-end application built using, as I said, web technologies like React. So the API is going to sit there in the middle. Or the API management solution, I should say, will sit there in the middle. And before we hand it over to Vamsi, I'm going to give you an example of these applications. So over here, I have a Kubernetes cluster. It's a Red Hat OpenShift dedicated cluster. You can think of it as an enterprise Kubernetes distribution. I have some applications running here in the back end, and one of them is a maintenance application, as I mentioned. So if we take a look at it over here, this is the development version of the application. I can log into it here. I'm already logged in, and I can see a list of occupied meters. But I could filter them by making a query to the API for out of service meters. And when I run this query, it fetches the results from our API, and I can see out of service meters. And if I was a maintenance engineer, for example, I could change its status to in maintenance mode. And I get a little update saying, hey, it's in maintenance mode now, and I can go out and do my job in the field. So this is all powered by a backend API. This is an internal facing application. But we may also have a more consumer-facing application, such as find available meters. So this application, someone could have signed up for it using a developer portal here, and they want to find open parking spaces downtown. So that this application could query our API to find available parking meters. You click on the parking meter here in the application that's available, and you click on Get Directions to get your parking. Fairly straightforward application, and it opens your Google or your Apple Maps if you're on your phone, and you get directions. And all of this is powered by a HTTP API, as I said, and the developers were kind enough to expose an open API spec here where we can see the methods. So you get meters, get a specific meter, and we can even use that post endpoint to update a meter's state if we were an internal city engineer. So now that you've got an idea of the kind of applications we could build, I'll hand it over to Vamsi so he can actually show you how to use Red Hat's OpenShift API management to implement an API management strategy, authentication, and other awesome features.
Thanks, Evan. So now that we've seen that we have a internal application here that initially had no API management at all. The front end was directly interacting with the API, but the IT team, say the IT team of the smart city, or let's say whatever city we are taking as an example, has thought that even for internal applications, we should make sure that there is enough security, and we should not just expose APIs as it is. So what they've decided is to implement API management product in between the front end and the API implementation, and they are leveraging Red Hat OpenShift API management for the same. So what this does is two things, right? One is it doesn't expose your API or your API server directly to the front end, and at the same time, it also increases security for the API because only authenticated users can access your APIs. How does Red Hat OpenShift API management enable that? I'm going to show you through a couple of examples. So first things first, this is the API that, this is the JSON result that is coming from the API that Evan just showed you guys. It's a JSON response from the API, which gives you the latitude, longitude, and the status of the meter, the ID of the meter, and whatnot, right? So we are going to use this, we are going to manage this API through our API management product and protect it and secure it through API management. So first things first, we'll create a product in our API management. What it actually means is a product is a way in which you can package multiple APIs together. For example, let me just say, let's create a product 1, and it's created. And once a product is created, you go to backends, and this is where you actually start adding your APIs, right? So I've already added the APIs, for example, the parking meters APIs. We have a sample API backend. So what you can technically do is, I'm actually going to navigate to the API that I already created here. So the city meters product is where I've combined multiple APIs from different domains and different backends, and package them into a single product. So you can use multiple APIs, multiple endpoints just from a single product. And the things that you see here are, the public paths. these are the paths that are relative to the product or relative to the gateway from which you can actually access these different backends. So what I actually mean by that is, for example, let's say you want to access the parking meters API, you have to go to the URL of the gateway and just access the, from the base path, you can access the parking meters. If you want to access the eco API, you have to go to the eco path of the gateway to access this. So now what I'm going to show you is the different applications that we've created. So how it works in our API management is applications are end user. These are end user applications that subscribe to the API through what we call application plans. So think about application plans as your traditional, say you're subscribing to Netflix, you have this different subscription tiers, right? So application plans are the plans that you've designed for your APIs, right? How many times can they access your APIs in a minute? What is the pricing and all that kinds of stuff you can do. So what I've done is we have created an application, an internal application with the name maintenance application that can actually access that once you create an application, a user key is assigned to it automatically, and only by using this user key can you access the API. So let's go and check what that actually means, right? So this is the URL of our API gateway. We provide both staging and production so that you can make all your changes in the staging environment, and once it's done, you can make it go live at the production environment. So first things first, let me do this and try to access the API with a user key is equal to, I'm not giving any user key here. It says authentication failed, right? Because our API management tool needs an API key that has been assigned to it in order to authenticate. So I'm picking the API key for this for the internal application here and throwing it in there to see if it actually works. There you go. So only if you have the API key can you access the API, and now your API is completely protected. External organizations or hackers are not able to access this if they're not registered through your API management platform. And if you give a wrong key, you don't get the access. And also all the error messages that are shown are highly customizable. All you have to do is you have to go to the settings and just change the error messages from here. Again, remember, we are not writing any additional code to put in security to your APIs. It is all UI driven, and you can do this automatically. So that thing is done. As I showed you, we've just checked one of the authentication method, which is the API key. And what happened next with the smart city scenario is, the API, the parking meters API that they developed really became popular. Now external organizations have started to reach out to the city's IT department saying, hey, you know what, we've realized that you guys have this API and we want to start leveraging it in our own products. Like for example, Evan showed us the Find My Parking API, or there could be an app which shows reviews about the restaurants and also would like to show if the parking meters are available with the restaurant. So all these different types of players or external organizations are reaching out to the smart cities IT department or the API development team saying, hey, we want to start accessing this API. But exposing APIs to internal applications is a different story, and exposing it to external organizations is a different ballgame altogether, right? But the API development team was really happy, and the product manager wanted to see what they could actually do to enable this use case. So the first things first is, as you can see, if you've seen Evan's example, and if you go back to the slide, if you can see this slide actually here, for the internal application, we give both get and post access, which means the maintenance engineer can get a list of the faulty meters and also update them and update the status through the mobile app. So we are giving access to both get and post methods through our internal app. But for the external app, the product manager for the API says, for the external app, we do not want to give a post access to the external apps. They should only be able to read the data, not write the data. And how do we do that? And the engineering team is talking to themselves saying, should we write any additional code for this to make that differentiation? Nothing. We just have to make changes on the API management platform to achieve those results. For example, we achieved that through application plans. For example, the internal plan, we've created different plans for different types of applications. For internal applications, we have an internal plan. For external applications, we have external plans. So if you see for internal plan, and the change meter status is a friendly name that I've given to the post method, and get meter info is a friendly name I've given for the get method. So here we've seen everything is enabled for the internal plans, right? Now, when we go to the external plan, we see the post access is still available for the external thing. So let's just check if the external apps are actually able to access the post method first. So this is the post method on Postman. I hope all of you can see Postman. Let me just check the chat. Yeah, okay. So I'm going to send a post request to change the status of a particular parking meter here from out of service to maintenance, right? So there you go. And it actually works. So this is the user key for external application, and the external application is actually able to access the post method. We don't want that to happen. We want to restrict external applications from actually accessing the post method. So what do we do now? So I go back to my API management platform, to my external application plan to which my external applications are subscribed, and just go and disable it and update my application plan. And now let's see what happens. Let me just clear the cookies, because Postman seems to cache results sometimes. And let me try to change this to available. See, authentication failed. Because now we've disabled the post access to the external applications. We see authentication failed. That means the external applications which are using this key that we assign to them cannot access the post method. So that's how we are restricting which method. Without making any changes in the code, we can actually restrict different applications from accessing different methods. And now since that is done, the next challenge for the product manager is, he sees that a lot of individual developers are using the APIs and making hundreds or thousands of calls in a very short period, and there's a lot of load, right? And they actually want to restrict the number of calls because the API has grown in popularity. They actually want to restrict the number of calls made by an external app based on their plan. So, for example, they can have a basic plan which restricts them to say 10 calls per minute and an enterprise plan which will say 1,000 or 100 calls per minute, right? Let's just throw some random numbers, and you can actually restrict that through application plans. So let me just go back to the APIs, and if you see here first, what I've done here is I've already configured the application plan for something called external basic. And what this means is, I've added limits saying if an external app that is subscribed to this plan can only make 3 calls to the API. So let me three calls to the API per minute. So this is the time period. So let me just go and check that out. Okay, before that, let me just go ahead and pick up the yes, because it's based on the user keys what it authenticates which app is accessing it. So I'm going to change the user key here. So if we make more than 3 calls, we should get a usage limit exceeded and the rate limit should get applied. So let's check that. Call number 1, there you go. Call number 2, call number 3, and the next call hopefully should say usage limit exceeded. Am I giving the right key? Yes, usage limit exceeded. So that's how we've applied rate limiting. Again, remember, we've not written any code, just by UI driven. Just by making changes in the UI, we've restricted the number of calls that can be actually made to the API. So the next use case is Oh, before I go there, right? I just like to show a couple of other things that you can do through application plans. So through application plans, you can actually also monetize your API. So if you want to start charging people for your API, you can set up have a setup fee, you can have cost per month, or you can have pricing at a method level. For example, if you want to charge users only for the post method and make the get method free, you can do that at a method level, and this will automatically generate invoices. I already generated a sample invoice that you can have a look at here. See here, it will generate sample invoices. Excuse me, need to log in. Sorry about that. So there's some error here, but anyway, so you can actually see the invoice generated here, and it'll actually generate PDFs that you can access. So that's and you can also we also have integrations with Braintree and Stripe for processing the payments directly on the portal. And the next use case is, now that everything is done, the API is increasing in popularity. The product manager reaches back to the API development engineering team saying, hey, the API has become so popular that now we can't, have email conversations with each of the API consumers to give them access. We need to create a self-serve mechanism so that users can discover and sign up for the APIs. Uh, Users can discover and sign up for the APIs automatically. And now the development team is thinking, can we achieve that using Red Hat OpenShift API management? Sure, they can. And how do they do that? Let me just get back to our platform here. Right. So if you go to the audience, developer portal. So what we give here is, out of the box, you get a developer portal that you can use to expose all your APIs. Users can sign up to your APIs, register for different plans, and get access to the different user keys, application keys, and the different authentication methods that they have. They can see statistics, and you can also customize the look and feel of the developer portal uh, using HTML, CSS, and also access the server-side variables to create your custom flows using the Liquid framework that's popularized by Shopify, the Shopify shops. And so let me just go and show you the API portal. So this is the portal where you'll actually expose your APIs, right? And you can register, get your API key, create your app or whatnot. What I've already done is, in the interest of time, I've actually created two users, one internal user and one external user, right? So what should technically happen is, again, I'm not going to change different portals. I'm going to use the same portal that will recognize an internal user and only expose them internal plans, and external user, and it will only expose them external APIs or external plans that they can subscribe to. So let's see how that is possible, right, through the demo. So I've already registered the users just for the interest of time. So let's say user1 at internalorg.com. So the internal org is when the system recognizes, oh, this user is an internal user, and we should only show them the application plans that are applicable internally. Sign in. So as you see, the internal users are only seeing the internal plans and are only able to sign up to the internal plans here, right? And they have no limits on how many times they can access the API, and you can also put a lot of other details, and they can create their applications or whatnot. But what happens if it's an external user? An external user should not be able to see these internal plans. Our developer portal should recognize that they are an external user and show them only plans that apply to them. So let's see if that actually works, right? User one at external org. There you go. So as you can see, we have different plans, right? The internal plan doesn't show up anymore here because I'm an external user, and the portal has recognized that I'm an external user, and it's showing all the limits. And it's also saying, I can't access the post method. and everything, and it masks all the internal features from me. So in that way, we can actually see, what you can actually customize based on the type of user, the experience, the look and feel of your developer portal, and without having multiple instances of it. And also another thing that I'd like to mention here is, I'm going to log in as another user here. Right. So the users, if they actually want to go ahead and test the APIs before they actually subscribe to the plan, subscribe to an actually plan, so they can actually access the documentation right from the portal. So, for example, we have our meters, the get meters by ID or the post methods, depending on if you're an internal user or an external user, and you can actually go ahead and try out those. The APIs from the documentation itself. For example, if I want to get the status of all the meters, I can do that. And if you're already registered to the application, which this user is, they can choose from the API keys that are already assigned to them in the documentation, so that it's easy. They don't have to remember the keys, and it's auto-populated, and they can actually check the type of results that they will get back from the API, so that they can start thinking about how they can use these results in their applications. So that's how you can access the documentation. But another key thing to remember is, for every API product that you create, you can actually add documentation to ActiveDocs. So ActiveDocs takes an open API specification or specification that's written in Swagger 1 or Swagger 2 and converts that into open into this type of a documentation that is in turn showed on the developer portal. So if you go and edit it, you can actually see the API specification that you have here, that you can make changes, and it will automatically get reflected on your developer portal. So that's where all this is coming from. You can also look at this. The end user can also look at the statistics of their APIs. For example, if they want to see how many calls that they've made, which methods they've accessed, and all the different stuff, right? They can see that right from the portal. And also, for example, it's always more often than not, it's always the fact that multiple users will be working on on a single application, right? For example, say an external organization is building an application using our API. There'll be multiple developers that will be working on that particular application. So if you can actually invite multiple developers that can log into the portal and access the applications and application keys that they have here. They can access all the credentials and whatnot. So that is how the developer portal actually makes it easy for discovering and signing up for the APIs without actually having to deal with API registration on a one-on-one basis, right? So that's how this engineering team has solved a problem of exposing their APIs to external audiences without the need to have that have that one-on-one conversation, and make it a more self-signed process where users can by themselves discover and sign up for the APIs. Now, what has happened is our smart city IT department recently had a security audit, let's say, and the results of the security audit were, they said for internal applications, having the API key as an authentication mechanism is all right, but for when you're giving access to external applications, I think it's better to have a higher level of security. And they had suggested, the Smart City IT department to use OpenID Connect and OAuth for their for authentication of their API versus a simple API key. So now the engineering team is tasked with this thing, right? They need to change the whole authentication way, and they'd like to see how they would want to leverage the Red Hat OpenShift API management platform for the same. So here we've created a product which says city meters, and all they have to do is they have to go to settings and choose the API authentication. For all the previous examples, we've used API key. Now I've changed it to OpenID Connect using OpenID Connect, and we are using Red Hat single sign-on for this, which is included with your subscription. So whenever you get Red Hat OpenShift API management, Red Hat single sign-on is included, and you have just all you have to do is you have to give the link of uh, the URL of the realm in the single sign-on instance for it to get connected. So this is the single sign-on instance that has all the clients that will get registered. And let's just see. Okay, let me just sign on. And sorry about that. Give me a second. So I'm just signing on to the single sign-on instance. And another thing to remember is it's not just Red Hat single sign-on that you can use for OpenID Connect. You can use any OpenID Connect issuer type here, and it would work in a similar way. I'm showing this example because this is included with the subscription of Red Hat OpenShift API management. So the important thing is, as I mentioned, applications are the end user applications that subscribe to our APIs. So once I create an application, say through this, say I'm choosing the external basic plan. Let's say SSO app. All right. Right. So as you see here, I've created the application. Our Red Hat API management has given you a client ID and client secret to the end user application. I mean, I've created the application directly from the admin portal, but ideally the flow will be, the flow would be from the developer portal, and that's when they'll get this client ID and client secret. For example, if I let's go through a diagram here, right? So the developer will subscribe to the API, and they'll be given a client ID and client secret. So as you see here, they've subscribed to the API, they've gotten a client ID and client secret, and our Red Hat API management has actually synchronized the client ID and client secret with the single sign-on instance. So if you check, it is 14db73f0. You will be able to find that right here, 14db73f0, and it will also sync the secret which our API management tool created, and we can also cross-verify that it's the same. So once that is done, what happens is, the developer app, in our case, I'm going to show this to Postman. The developer app will request a JWT token using the client ID and client secret. And once our Red Hat single sign-on instance authenticates it, it will send back, it will provide a JWT token. So let's see how that works. So this is I've already created the Postman request here. So this is the endpoint, and I'm using OAuth 2. I've provided the client ID, client secret, and the authentication URL and the token URL. And first, let's try to get the token. Right. So once we try to access the token, it will ask us for credentials. I am giving the credentials that we have. And it says open Postman. Proceed. And there you go. You have an access token that you can use to actually, access your API now. Let's go ahead and analyze the token a little bit on jwt.io. Right, there you go. So if you actually go ahead and paste your token here, you can actually see the different permissions that are coming from there and the different scopes. You can use this to make complex role-based access control operations. But for now, we are just going to use it to access the API and get the result. So now that we have the token and the authentication URL and the access URL, client ID, and client secret, I'm going to go ahead and make the request. Let's go ahead and click send. There you go. So we get the status of all the meters, the same result that we got from our GET request, all the details, but we've changed the authentication method, and we've gotten that. So that kind of brings us to the end of all the scenarios that we wanted to talk today. But all in all, what we wanted to show is, without the need to write any code, you can protect your APIs using Red Hat API management. You can change the different types of authentication methods that you'd like to leverage, or that you'd like your API to use or leverage, without the need to write any code, and you can build a secure APIs and expose it to external organizations, and even monetize it if you see the need. If there are any questions, I'm happy to answer if we have more time. But please feel free to jump onto the Red Hat booth if you have any questions. I'll be there for the next half hour to 1 hour, and be more than happy to answer any questions that you may have.